With rapid technological advances in the diesel engine industry, often resulting in changes to maintenance practices, Cummins is committed to supporting the network of highly skilled technicians who maintain and repair our engines for years of customer satisfaction. To underline this commitment, Cummins has developed and maintains an active training philosophy that assures these service technicians are the best in the industry. This program will cover the newly developed procedure for spill port timing in an inline fuel pump. A properly timed fuel injection pump is critical to the optimum performance and emissions of the engine. Incorrect timing will affect engine power, cylinder pressure, emissions, and visible white or black smoke. Fuel injection is timed relative to engine rotation as the piston moves toward top dead center of the compression stroke. When fuel injection is timed too early, injection occurs before the engine is rotated to its proper position. This results in the injection spray being improperly directed into the piston bowl, allowing fuel particles to be distributed around the cylinder. Some of these fuel particles will contact quench areas and not be burned completely. Early injection will cause peak compression pressure and peak combustion pressure to occur at a point that will raise the total cylinder pressure beyond the design limits of the engine and result in engine damage, increased emissions, and black smoke. When fuel injection is timed too late, maximum burn pressure occurs after top dead center. Thus, the maximum cylinder pressure and temperature is reduced, and black and white smoke will develop. If the air coming into the cylinder is cool, there will not be sufficient temperature created to ignite all the fuel, and white smoke will be most prominent. If the air coming into the cylinder is normal or hot, the fuel will reach the required temperature to ignite the fuel particles. But because the particles are improperly directed into the piston bowl, some particles will contact quench areas, resulting in incomplete combustion or burn and produce black smoke. Under normal circumstances, the timing pin and fuel pump timing pin procedures will produce a correctly timed fuel pump to engine. In the event that engine performance problems still exist, Cummins has developed a new procedure called spill port timing to verify top dead center and fuel pump to engine timing. The spill port timing procedure should be used according to the troubleshooting trees in your troubleshooting and repair manuals. Before demonstrating the actual spill port timing procedure, it's important to note the basic operating principles of the injection pump at this point. The following sequence of plunger lift and retraction illustrates the pumping action for moving fuel from the gallery to the engine cylinder. At bottom dead center, fuel from the gallery fills the bore between the plunger and the delivery valve. As the plunger is lifted, the fill port closes, sealing a quantity of fuel in the bore. Continued lifting of the plunger reduces the volume above the plunger, thus creating the fuel pressure necessary for injection. Injection ends as the helix on the plunger reaches the spill port and the pressure above the plunger is released. For our purposes, we will rotate the engine so that the pumping element is in the fill position. We will then put fuel under enough pressure to fill the bore. Lift the delivery valve off its seat and allow fuel flow through our test line. Then we will rotate the pump, lifting the plunger just to the point that we achieve port closure. The flow of fuel should now be reduced to a chain of droplets. This is the point in normal engine operation where pressure is built up above the plunger just enough to begin fuel injection. In order to have proper timing, this must occur when engine rotation is at the specified degree before top dead center. To begin the spill port timing procedure, the shutoff lever must be kept in the run position, either by mechanically wiring it or by energizing the solenoid. Next, the governor on the injection pump must be set so that the helix on the plunger is in the running full fuel position. This is accomplished on the P7100 pump with the RQVK governor by positioning the governor control lever for full speed. This allows the rack to move the plungers from the shutdown position to the run position. Note, other inline pumps with different governors may require additional procedures to locate the plunger position. However, in any case, the objective is to position the plunger in the run position regardless of any unique plunger design. Depending on the application, this procedure may require two people, one to bar the engine at the flywheel with the barring tool, and the other to observe the position of the engine and the flow of fuel through the test line. All referencing for the procedure will be done with number 1 cylinder on the compression stroke. Due to the inaccessibility of the engine timing pin on many applications, we will be using the valves on cylinder number 1 as the positive stop method to locate top dead center. To determine if the engine is in the compression stroke on cylinder number 1, look at the valves on cylinder number 6. With the valve cover on cylinder number 6 removed, rotate the engine clockwise until the exhaust valve is closing and the intake valve just begins to open. At this point, the cylinder number 1 piston is nearing top dead center and is on the compression stroke. However, if access to cylinder number 6 is difficult, simply observe the intake valve closing on cylinder number 1 as you rotate the engine clockwise. As the intake valve closes, you should feel lash in the rocker lever. Then, rotate the engine clockwise approximately 1/3 revolution. The piston is now near top dead center. In either case, rotate the engine past top dead center compression stroke by approximately 45 degrees. As you can see, by observing valve overlap on cylinder number 6, this method is more precise in determining where the engine is in reference to top dead center on cylinder number 1 than merely observing the intake valve on cylinder number 1. Once you're approximately 45 degrees past top dead center, loosen the lock nut on the intake valve adjusting screw and rotate the screw clockwise 5 turns. Due to valve geometry, 5 turns down of the intake valve adjusting screw will better position the valve for accurately locating top dead center than previous methods. If you can't turn the adjusting screw down 5 turns, you will have to rotate the engine clockwise slightly. Caution. Push rod or valve damage can occur if the engine is rotated too quickly or too hard as the piston makes contact with the valve. Notice how much effort is required to rotate the engine so as to be able to recognize when mechanical contact is made. Bar the engine counterclockwise until you feel the piston contact the intake valve. Attach a magnetic-based pointer to the front cover above the damper and precisely place a mark on the damper aligned with the pointer. Now, bar the engine clockwise until you feel the piston contact the intake valve again. Precisely mark that position on the damper aligned with the pointer. Caution. Be careful not to move the pointer, as this is your reference and must be precise. Measure the distance between the 2 marks on the damper, then determine half the distance between them. This halfway point is top dead center. Precisely mark this position on the damper. Back off the intake valve adjusting screw 5 turns. As you will recall, we started with the engine at top dead center of the compression stroke, and during the process we've rotated the engine through the power stroke and near the top of the exhaust stroke. Now, bar the engine clockwise approximately 1 revolution until the top dead center mark for cylinder number 1, compression stroke, is aligned with the pointer. Note, if the engine timing pin is accessible, you may want to verify that it is in good condition and will engage. If necessary, replace or relocate as required. Measure the diameter of the damper in order to determine which degree tape to use. You will have to use a degree tape that is incremented to the appropriate damper diameter. Attach a piece of 3/4 inch width magnetic tape to the back of the degree tape, and then attach this magnetic degree tape to the damper with the 0-point degree at the top dead center mark. Bar the engine counterclockwise 30 to 40 degrees before top dead center. This will position the fuel pump so we will be able to obtain fuel flow through the pumping element later in the timing procedure. To remove the fuel line for number 1 injector and pump, loosen the fuel line clamps and flare nuts. Be careful not to bend the fuel line when removing it. All other fuel lines should remain attached. Place a protective cap over the injector to keep dirt and other contaminants from getting into the injector. Remove the fuel supply line from the inlet of the injection pump. Then, remove the overflow valve and drain line. Note, if the clearance between the fuel pump and cylinder head is not adequate to remove the overflow valve, file or grind away a small portion of the cylinder head material to obtain the required clearance. Now, replace the overflow valve with a plug. The overflow valve has also been referred to in earlier programs as the vent fitting or fuel return fitting. Attach a modified fuel line to the number 1 delivery valve. With this attachment, we will use a short piece of clear tubing to view the fuel flow and then additional tubing to route the fuel back to the supply tank. Next, attach an auxiliary pump that will supply the required volume and maintain 300 to 350 psi into the supply line of the injection pump. To review, inside the fuel pump, the port in the number 1 barrel is fully open. Fuel will be pumped into the barrel using an auxiliary pump through the fuel supply line, applying 300 to 350 psi. The pressure will open the delivery valve and allow a stream of fuel to run out through the test line. At this point, we'll begin the procedure. With all the plumbing attachments made and the auxiliary pump functioning, apply 300 to 350 psi to accomplish a fuel flow that can be observed through the window on the modified fuel test line. Beginning at approximately 30 degrees before top dead center, rotate the engine clockwise very slowly while observing the fuel flow. Continue rotating the engine until the flow is cut to a chain of droplets or no less than 2 drops per second. Stop rotating the engine at this point. This point defines port closure and the beginning of injection. At this point, shut off the auxiliary pump. Now, observe the degree tape on the damper and read the number of degrees from 0 to the tip of the pointer. Compare this reading to your timing specification on the engine data plate. If the specification on the data plate matches the degree at the pointer on the damper, the pump and the engine are timed properly. If the specification on the data plate does not match the degree at the pointer on the damper, within plus or minus 1 degree, an adjustment must be made. If the injection pump is at port closure, and injection is occurring too early or too late, the problem is that the fuel pump timing or installation was done incorrectly. To correct or verify the timing problem, we will retime the engine to the fuel pump. Earlier in the procedure, we positioned the fuel pump at port closure by observing the fuel droplets. At this point, the fuel pump is at the proper spill port timing position. Therefore, we will be repositioning the engine while maintaining proper fuel pump position. To adjust the engine position, disconnect the pump drive gear from the fuel pump. Break the pump drive gear nut loose. Turn the auxiliary pump back on and verify that the injection pump is still at port closure by observing the droplets in the window of the test line from cylinder number 1. If the injection pump has rotated, it must be repositioned to maintain the specified droplets. Now, turn off the auxiliary pump. Install a puller and pull the fuel pump drive gear. Rotate the engine counterclockwise a few degrees. Now, rotate the engine clockwise until the specified degree on the damper tape is lined up with the pointer. Always come to this specification in the direction of engine rotation. Note, the fuel pump gear and shaft taper must be clean and dry to prevent any slippage during installation or operation. Remove the backlash between the cam gear and the fuel pump drive gear by rotating the fuel pump drive gear counterclockwise while pushing the gear onto the fuel pump shaft taper. Install and tighten the retaining nut to the first torque, 106 inch-pounds. This will seat the gear on the shaft taper. Then, apply the final torque of 122 foot-pounds for the P7100 pump. As a final check, turn the auxiliary pump on and rotate the engine counterclockwise to approximately 30 degrees before top dead center, or until there is a flow of fuel through the window in the test line. Rotate the engine clockwise very slowly until you observe a chain of droplets, or no less than 2 drops per second, and then stop rotating. Observe the pointer and the degree tape on the damper. It should be at the specified degree, plus or minus 1 degree. The spill port timing procedure, when performed properly, can accurately determine injection pump to engine timing. To verify the fuel pump timing pin to tang location, rotate the engine clockwise to the top dead center mark. Attempt to install the fuel pump timing pin. If it seats on the tang properly and will not rotate, then the fuel pump timing mechanism is okay. If the fuel pump timing pin cannot be installed due to misalignment of the timing pin and the tang, the fuel pump timing mechanism should be repaired at an authorized repair station. To complete the procedure, use a feeler gauge to check the valve on cylinder 1 for clearance to make sure it's adjusted properly. Then, reinstall the valve covers on cylinder 1 and cylinder 6 and the front cover cap. All fuel lines must be reinstalled, including the fuel supply, drain line and overflow valve, and the number 1 fuel line. Be sure not to bend the fuel line when reinstalling it. Properly position the fuel line into the rubber clamps and torque the clamps to specification. This procedure must be applied according to the troubleshooting trees in your troubleshooting and repair manual. Remember that the primary procedures for fuel pump installation and for locating top dead center are still the engine timing pin and the fuel pump timing pin procedures. Today's engines require specific combustion bowl design with optimum engine timing to meet required performance and emission standards. Cummins service procedures will allow you to troubleshoot and service the engine and return it to its original design criteria. By using the spill port timing procedure and the positive stop TDC method, you can verify injection pump to engine timing. In difficult access applications, this procedure becomes even more useful. It will save the customer unnecessary downtime and repair expense.